Good afternoon. Is everybody awake now? So I bet you thought we would have a Watson ad, but we actually wanted to feature one of our clients, Red Bull Racing. And I wanted to feature it because if we think about Red Bull Racing, it's really the epitome of many things that we're discussing here at ITEXPO. First of all, they're a formidable engineering company, as we all know, to do what they've accomplished. But they're also very progressive from an IT perspective. I had the pleasure of visiting Milton Keynes outside of London and experiencing Red Bull, going through the entire design process with their engineers, seeing how they construct the car with their 3D printers, their advanced tooling shop. It's really fascinating. They managed to win over a period of 4 years, consistently, 4 years in a row. Of course, we all know Formula One continues to change things up. They're regulated as well. So when you think about what they're doing, they're using state-of-the-art design. You can see here they're making 30,000 engineering changes a year. They're using an advanced simulation cloud to do simulation from an air tunnel simulation perspective, every aspect of it, because with Formula One, you are regulated both on your track time and your simulation time. So it's all about advanced modeling to be able to get this result in a desired amount of time because you only have so much time and it's very closely tracked. And not only this, but of course the car is an IoT-based device. It is instrumented, and during the track race, they're able to, at Mission Control in Milton Keynes, observe the behavior of the car. They've all got their headsets on, and they're able then to use Monte Carlo simulation in the middle of this race to then give advice to the driver. And yes, this car does not need a driver, but it, once again, is required to have a driver by Formula One. So it is an autonomous vehicle already, but it's just fascinating. And I think we can all take away some learnings from what is done here and perhaps apply it to what we're all trying to get to as we look at the evolution of infrastructure in many of our enterprises. I think that Chris actually did a good job talking about this data explosion, but literally I think data is at the pinnacle of much of what we're trying to deal with. And it really is driven by this social, mobile, IoT, Internet of Things phenomenon, and it's driving an exponential change in many organizations across every industry that we deal with, certainly. Because how do we get the value out of what is a mountain of unstructured data? And more so than that, there is no systematic metadata tagging in many cases to understand how we can pull out the data that we really need access to. And then that's what we say here, that a lot of the data is unusable. And of course, 80% of the data is in cold storage and not ever looked at again after about 90 days. So there's a tremendous amount of inactive data out there. So all of that's driving this next generation of killer apps, which are analytics-driven applications, right? How are you going to deal with all of this without advanced analytics? So that is driving most industries from what is called the programmatic era to this cognitive era. And whatever term you use, whether it's artificial learning, machine learning, deep learning, all of it's really a journey to have a much more learning process as part of what we have to go through in processing this data. So it's about creating a cognitive ability that actually has the ability to understand, reason, learn, and interact in different ways. We're experiencing this with many different devices in our lives today. And of course, these are the foundational elements of what we're investing in IBM, not in terms of not only what we do with Watson, but in many of the things we're investing in around deep learning and machine learning. Most of our clients are dealing with this data tsunami, but they're also trying to understand what is the infrastructure of choice for me to deploy in my organization. And most often, I find that organizations really want to have choice. They really want to avoid lock-in. They want to understand and have flexibility of data and workload location. And so when I think about hybrid cloud, I think about it more practically from this standpoint of flexibility about being able to move your data and your workload. Because perhaps today I want to do things on premise, tomorrow I want to take advantage of a service provider or a cloud provider, and I may then decide I want to bring things back in-house. It's the way we've always navigated around the world of IT. To me, a lot of this is just the modernization of outsourcing, if you will. At any rate, it's about being able to use partners systematically to get your job done And I think that's part of what's behind this drive to hybrid cloud. When we think about some of the key tenets that we see exploding across our client community, it really is these three things, right? It's about collaborative innovation, and what we mean by that is this advent of ecosystems, open ecosystems. And those open ecosystems are really there to allow us to get more benefit at an increased rate of speed, if you will. It's also about understanding how you need to design for this cognitive era. What are some of the considerations that you have to think about? Because in fact, if you are in the world of semiconductors, which I know some of you are, Moore's Law is coming to an end. So how are we going to get the advantage out of our compute infrastructure? It's going to be driven by new ways of hardware acceleration, and of course it will continue to be influenced highly by software automation. Software-defined infrastructure, of course, is very prevalent in many of our organizations. So these are going to become even more important with the end of Moore's Law, and of course organizations like ours are also working on the next big leap of computing, which is quantum computing. Last year, IBM came out with a quantum experience that all researchers can work with through the cloud, if you will. Our quantum computer is hosted in our Yorktown research facility. It's very cool stuff. You know, it has to run at absolute zero, so we have these cryogenics units, and we have the qubits inside those cryogenics units. But that's the next level beyond, you know, what we've traditionally thought of as computing. We have to live another day, right, until quantum really becomes a full realization for all of us. And of course, we have to have this flexibility, the speed and economics of this cloud environment. So when we think about what's happening in this ecosystem area, I would think about it in terms of, first and foremost, the developer. I think a major stakeholder at play here is the developer. From my perspective, whenever there's this big shift in IT, the developers become more powerful, and some of you are probably developers, and perhaps you do feel powerful. I started as a software programmer in an IBM, and some days I don't feel so powerful, but clearly we see the advent of the developer here with the power because they're using things like these open API offerings, if you will, these open-based construction approaches to create new applications at a very rapid rate and speed. That means vendors like IBM and many others in the industry have to surface our capability as APIs. Many of you, regardless of industry, have to surface your capability as APIs. I was meeting with financial institutions this week, and they are making all of their services available through APIs so that their developers can be more effective as well as their partners be more effective. But construction of these new apps is also fueled by the use of open technologies at even a more rapid rate and pace than what we've seen in the past. So if you're interested in these new construction methodologies, you might be using tools that are based on Open Foundry. IBM has one of those called Bluemix. There's also the use of open technology like Docker for the container environment. There's the evolution of these open frameworks like Caffe and TensorFlow for artificial intelligence becoming very, very prevalent out there among many clients. And of course, every industry is looking at ways that they can use this to their advantage. And of course, the evolution of open operating systems around Linux, all very, very critical, but increased utilization of this. So these developers are then driving workload into the environment at a rapid clip and pace, and all of this has to be secured and managed and optimized still to meet the needs of the business. A few examples of what we've done around this area of open collaboration is, first of all, we've collaborated with this foremost Chinese cloud provider, Tencent. I don't know if you all know Tencent, but Tencent supports a variety of industries in China, and including, they're the hoster of the WeChat social program that many folks around the world use. They have about 900 million users of WeChat on a monthly basis. But we were able to execute a new benchmark with Tencent here that operated 33 times faster than what had been achieved before, allowing us to sort more than 100 terabytes of data in 99 seconds. And we did this through our Open Power initiative, working with this Chinese cloud provider. Without opening up our architecture in this way, we certainly would not have been able to form this partnership with this particular cloud provider. Another example I think that you are talking about here at the conference is the evolution of open technologies around Hyperledger for blockchain. We fundamentally believe blockchain will be a huge game changer for many industries. It's starting in financial services. We talked about Bitcoin a little bit earlier, but clearly one of the major outcomes of the effort was this notion of this electronic ledger, if you will, or this digital ledger. One of the more interesting uses of a blockchain from our perspective has been the use by Everledger to ascertain and manage diamond provenance. So they're managing the provenance, creating a digital signature for about 1 million diamonds, if you will. This allows us to have provenance of those diamonds throughout their life and guarantee the buyers that they have the right origin, and also manage many of the other conflict-free aspects of these types of rare minerals that we'd like to have managed across the world. A very unique implementation of blockchain, but it shows that blockchain can be stretched well beyond financial services to other industries, and I think we'll see that more in the future. So when we look at cognitive, what are some of the other things that we have to think about? Well, if we think about data, first and foremost, everyone's worried about data economics. So how are we going to get data economics? We believe that's where things like software-defined infrastructure, software-defined storage, and flash storage are coming into play in a significant way. Also, we have to think about this life cycle of the data, right? The data, in many cases, moving from very hot, which means I need to access it more frequently, to warm, to cold, even deep cold storage. And perhaps if you're in an industry where you have a lot of compliance obligations, you've got a lot of data in cold storage. So how do you automate and manage the temperature of this data? You have to have the intelligent, you have to have some sort of fabric that's going to allow you to do that, and that's something that we have definitely invested in to be able to manage the temperature of data, and once again, to manage the locality of data so that you could have it on-prem, off-prem, and have that flexibility of where you actually put that data. And then last but not least is then we want to get insight from the data, and that's where the new techniques around machine learning are coming into play. And we see a lot of, we are certainly doing a lot of work around acceleration, advanced acceleration of things like in-memory databases to be able to allow us to process huge amounts of data, but in the right amount of time to get that business insight. There are many problems today that still are not completing in a reasonable amount of time, and of course that's what will drive the evolution of things like quantum in the future, because there's difficult problems we still cannot solve with even modern computing and acceleration today. So some examples of some newer firms. This one's actually in France that's using artificial intelligence for a new monitoring solution, helping their clients be more predictive about operational challenges. And if you have complex operational environments, you know that when something goes wrong, it is like finding a needle in a haystack, and you have to find it fast. And often the most valuable piece of data that you might need is often a log somewhere, and of course a lot of the alerting mechanisms you can't set to have so many alerts coming off all the time, so that a lot of this log data may be data that is not as usable in a very finite amount of time. And so this is an example of a company that's pulling all of that together, and there's other examples, of course, but applying artificial intelligence to be able to deliver the results more quickly. Likewise, another organization that is using artificial intelligence for cyber threats. Once again, there's a huge amount of data. They're looking at 300 gigabytes of data per day, and then trying to cipher through millions of events to understand what to recommend to their clients. This is a newer company out of Texas, and they're using artificial intelligence to achieve this new service. So last but not least is this idea of cloud. As I said before, it's about enabling developer productivity. It's about enabling flexibility of workload placement. So the things we have to understand is what are some of the capabilities that we provide to allow workload placement. We have partnerships with firms like VMware, for instance, allow us to move the data from VMware on-prem to VMware on the cloud. We certainly see the use of advanced container technology to be able to have improved locality of workload. And of course, we have software-defined storage, and most prominently today, object storage that allows us to create movement of data both on-prem and off-prem through an object storage software layer. And we think that the use of object storage will continue to be more prominent because, in fact, we have a growth of very large objects, whether that's video, voice, and other things that I think is very important that software-defined storage can help us with the economics of that. And last but not least, I hope that all of you that have successful businesses out here have actually thought about your business continuity and your disaster recovery plan. But we actually see, because I own client support worldwide for all of our systems business, I can't tell you how many customers show up every week who actually have no reasonable disaster recovery or business continuity plan. Because think about the amount of data that we're able to store on a single storage device. It's a huge amount of data. You can actually put, well over a petabyte easily on some of these devices. How much time do you think that it takes to recall that kind of data? I see many large companies where we have a situation where it's going to take 3 days or more for the data to come back. So you have to ask yourself, is that what you expect when something happens? You want your data to come back in 3 days. Do you have high availability? Do you have a reasonable disaster recovery plan? We're almost forgetting how much data we're managing and how much data we need to have available to run our businesses sometimes. And so I think cloud models and hybrid cloud models can certainly help us with this notion of business continuity. We were speaking about cybersecurity or security a little bit, but also I see a lot of regional health organizations where not only do they not have this disaster recovery plan, but they are frankly at risk of being hacked and not having access to any of their data. And so this is a serious issue that I think that some of these new models will help, hopefully help those organizations be able to conquer by the easier movement and more economical support of DR and disaster recovery. And that's something that we are investing in quite a bit. So an example of a large financial firm, I couldn't actually put the name here, but this is important because this is a private cloud implementation hosting over 400 capital markets and risk applications. They've improved their chargeback by 260 times. Basically, their chargeback went from $8 per gigabyte per month to $0.03 per gigabyte per month using a software-defined infrastructure. Now, that is exactly the kind of promise that we all expect to get out of a cloud environment. This is an example of an on-premise implementation, but really manifesting a lot of the characteristics you see in other clouds. Once again, it's allowed them to achieve and save billions of dollars, frankly, from a compliance perspective within their industry. Another interesting example is a German government-focused service provider, and this is where they're using object storage heavily to store a lot of data for their clients, but also, once again, get the economics around things like backup and recovery. One of the other things that I see from a client support perspective is actually I get end clients who are using a service provider, and many of you may be service providers, where they don't necessarily understand what they're paying for. They don't understand the SLA that they paid for. They believe they've got data recall in a certain amount of time. They believe they've got high availability in certain aspects of DR, but when something goes wrong, they sometimes find out they actually did not pay for that. And so this company, I think, is doing some interesting things here to try to make some of those services more economical so that people are willing to pay for it. It's kind of awkward for me when I have the end customer come to me and say, what did my service provider do wrong? Because they're actually my customer, so I have to send the end customer back to the service provider, and they have to have these discussions about SLA and what they actually paid for. So it's something that I think is advantageous for any of you that are providing these kinds of services to certainly think about as well. And I know that was a really quick run through, but I was told that I was right before the cocktail hour, and one of my policies is if you go too long into the cocktail hour, it's not generally a good thing. But hopefully you got to take away a few elements of what we're focused on at IBM and what we see our clients focused on. And once again, it's really about this hybrid cloud movement. It's fueled by data, and hopefully we'll all be getting smarter and implementing AI machine learning so that we can get the insight out of data that's required to make our businesses more effective. I appreciate your time, and I actually will be stopping by the expo in the booth if there's questions, and would love to talk to some of you, and hope you have a great conference. Thank you.